Hello, sixth period pre-cal. This is Mr. Allison, and I can't be here today. I'm attending the Governor's Arkansas School Safety Commission, and I'm going to leave you with this lesson on video. And first, I want you to notice your student-friendly learning objective, because you can't learn without student-friendly learning objective. If someone would please pause the video and write this down on the board so that you can reference it numerous times throughout the lesson. I will factor quadratic equations of the form ax squared plus bx equals 0. Notice a quadratic equation where c is 0, and ax squared plus bx plus c equals 0. In this case, we're mainly focused on when a is not equal to 1. We did a equals 1 yesterday. Here, we can have 1 or not 1. We're going to do this by factoring out. We're going to take a look at this first form, ax squared plus bx equals 0. And we're going to do this by pulling out what's called a common factor. If you had the expression 3x plus 6 in the past, you learned to factor that by saying there's a common factor of 3 here and a common factor of 3 here. And you pull out the common factor and you ask yourself a question. What times this 3 would give me 3x? That would be x. And what times this 3 would give me 6 plus 6? That would be plus 2. And that's how we factor an expression, a binomial. We look for the greatest common factor in both terms. We pull that greatest common factor out and ask ourselves the question, what times the greatest common factor equals the first term? That goes here. And what times the greatest common factor equals the second term? That goes here. So if we have a quadratic equation here, the greatest common factor between ax squared and bx is x. So I'm going to pull it out. And I ask myself, what times x gives me ax squared? That's ax. And I ask myself, what times x gives me plus bx? And that's plus b. And that equals 0. So we can factor ax squared plus bx as x times ax plus b. And then we could set each factor equal to 0 and solve. So we get x equals 0. And ax plus b equals 0. This is already solved for x. And you think about it, we plug in 0 here. We get 0 plus 0 equals 0. That's a solution. Here, we would subtract b from both sides and divide by a, and see that x equals negative b over a is a solution. Let's do one like this with numbers. So let's plug in number 5 times x squared plus, let's do 15x equals 0. Notice in the numbers, the greatest common factor is a 5. This is 5. This is 5 times 3. I'm going to pull out that greatest common factor of 5. But then let's look at the greatest common factor in the variables. X squared is x times x, and x is just x. So there's 1x here, 2x's here. That makes 1x in common. So the greatest common factor between 5x squared and 15x is 5x. Now I ask myself the question, what times 5x gives me 5x squared? That's x. I ask myself the question, what times 5x gives me plus 15x? And that's plus 3. So we can see that 5x squared plus 15x factors to 5x times x plus 3. Then we set each factor equal to 0 and solve. So that we divide both sides by 5 and get x equals 0 over 5, which is just 0. We subtract 3 and get x equals negative 3. And these are solutions to this quadratic equation. This is the factored form of 5x squared plus 15x. And this is how you do all of these binomials where you have an x squared term and an x term, and a constant term is 0 for the quadratic equation. So now let's look at a little more complicated example when we have ax squared plus bx plus c equals 0, where a is not equal to 1. It's going to be similar to what we did yesterday when a was 1, but this time we're going to look for two numbers that multiply. Instead of just multiplying to make c, we're going to look for two numbers that multiply to make a times c. And the same two numbers still have to add to make b. Now the trick is what comes next. When we find those two numbers, if we call those numbers r and s, we are going to notice that if I take this equation and I multiply both sides by x, if I multiply x times r plus s, I would get rx plus sx, and that would equal bx. That allows me to replace the bx in this equation. I would have ax squared plus, I still have the plus c, I'm only replacing the b times x with what it's equal to, rx plus sx. I'm replacing the middle term with what it's equal to. When I find these two numbers that do this, this equation will factor. And I can see by r plus s equals b means rx plus sx equals bx, and I can replace bx with what it's equal to. After I do that, I do what's called factoring by grouping. I group these two pairs, and I pull out common factors in each one. And let me show you with numbers what's going to happen after that. So let's take the equation 2x squared plus, let's say, 6x minus 8 equals 0. My a is 2, my b is 6, and my c is negative 8. So I'm going to look for two numbers that multiply to make a times c. 2 times negative 8 is negative 16. Same two numbers have to add to make b, which is 6. Now 8 times negative 2 makes negative 16. And 8 plus negative 2 makes 6. So here I'm going to replace the 6x with 8x minus 2x. These two expressions are equal. So I can replace in here 6x with 8x minus 2x. So I'll write 2x squared plus 8x minus 2x minus 8 equals 0. And now I'm going to factor out these two pairs. I'll look for a common factor in this pair. 2 is a common factor between 2 and 8, and x is a common factor between x squared and x. So I'm going to pull out 2x, and this factors to 2x times, the question I ask is 2x times what equals 2x squared, that's x, and 2x times what equals plus 8x, that's plus 4. Now here, when this leading term in this pair is a negative, I'm going to pull the negative out with it, and the common factor is negative 2. I ask myself, what times negative 2 makes negative 2x? That's just x. I ask myself, what times negative 2 makes negative 8? And that's plus 4. Now, two things we can do here. We can either, just notice now that this factors to 2x minus 2, what's outside the parentheses, times x plus 4, what's inside the parentheses. You may ask why that is, and I'm going to tell you that that's because x plus 4 has now become a common factor. And if we pull that x plus 4 common factor out and ask ourselves what times x plus 4 equals 2x times x plus 4, that answer is 2x. And if we ask ourselves what times x plus 4 is negative 2 times x plus 4, that answer is negative 2. So this factors to this. One thing we can also notice here, didn't mean for this to happen, but it did. There's a common factor here. I can pull that out. 2 is a common factor, and 2 times x gives me 2x, and 2 times negative 1 gives me negative 2. So this expression, 2x squared plus 6x minus 8 equals 0, can be written as 2 times x minus 1 times x plus 4 equals 0. I can solve this equation by setting each factor equal to 0. Taking all real number solutions. 2 is never equal to 0, so I throw that one out. X minus 1 equals 0 when x equals 1 by adding 1 to both sides. X plus 4 equals 0 when x equals negative 4 by subtracting 4 from both sides. So my solutions to this equation are x equals 1 and x equals negative 4. Let's try one more real quick, because that didn't work the way I wanted it to. I didn't want it to be like that. I didn't want the common factor 2 here. Let's do one. Well, I hope you saw that. Where we have, let's say, 6x squared plus x minus 2 equals 0. Here, my a times c, that's going here. Two numbers multiply to make a times c, that's negative 12. The same two numbers have to add to make positive 1, because this is a positive 1x. What two numbers make negative 12 when I add them? Negative 3 times 4 makes negative 12, and negative 3 plus 4 makes positive 1. So I'm going to rewrite the middle term as negative 3x plus 4x. So this is going to become 6x squared minus 3x plus 4x minus 2 equals 0. I'm going to take this first pair and this second pair. There's no negative here, so I can pull out a plus this time. I'm going to look for the greatest common factor in the first pair. That's going to be 3x. Ask myself the question, what times 3x gives me 6x squared? That's 2x. What times 3x gives me negative 3x? That's negative 1. Pull out the greatest common factor between 4x and negative 2. It's plus 2. Ask myself what times 2 gives me 4x? That's 2x. And what times 2 gives me negative 2? That's negative 1. You can see I have the common factor of 2x minus 1. So this becomes 2x minus 1 times 3x plus 2 equals 0. This is the factored form of the quadratic expression 6x squared plus x minus 2. And this, to solve this equation, I would set each factor equal to 0. Sorry. And solve. Add 1 to both sides. Divide by 2. Get x equals 1/2. Subtract 2 from both sides. And divide by 3. And get x equals negative 2/3. And those are my solutions. And this is how you factor to solve quadratic equations of the form ax squared plus bx equals 0 and ax squared plus bx plus c equals 0. Now you'll have an assignment. I'm going to show you, give you the assignment, and I'm going to go ahead and give you an example. Start. This is what's called a circuit. Should have put that on there. This is a self-checking homework assignment, or self-checking assignment, so you can see if you did it right. And what will happen is we will look for an answer. We're going to factor each equation, then enter the number in the cell with the answer that matches yours. So we look at this cell. We want to factor this equation. That's all I'm asking you to do here, not solve it. So we want to write this in factored form. So I'm looking for two numbers that multiply to make 6 times negative 3 is negative 18. Same two numbers have to add to make 7. And I'm going to find those two numbers. That would look like 9 times negative 2 would be negative 18, and 9 plus negative 2 makes 7. So I'm going to rewrite the middle term, 6x squared plus 9x minus 2x minus 3, because remember, using these numbers, 9x minus 2x equals 7x, to replace the middle term. Now I'm going to factor each of these two groups. The greatest common factor here is 3x. 3x times 2x makes 6x squared. 3x times plus 3 makes plus 9x. I'm going to put a negative here. Now there's no common factor that we see here, but there's always a common factor of 1, so I'm going to pull out a negative 1. And I'm going to ask myself what times negative 1 makes negative 2x, and that's 2x. What times negative 1 makes negative 3, and that's plus 3. So I have my common factor now of 2x plus 3. And now the outside was 3x minus 1. So this factors to 2x plus 3 times that 3x minus 1. So now look for those answers. 2x plus 3 times 3x minus 1 is here. That's the matching answer. This was problem number 1. So I enter cell, or problem number 1 in that number. Then I work this solution, find this answer, match it to one of these others, and enter number 7 there. Then I'll mark that problem and match it. And in the end, you should have used up all numbers 1 through 10. So enjoy your lesson today. I'll be back on Wednesday.